So, handing a task off to a sub-agent gets sold as a token savings move, and that is true. It is the shallow reason to do it. What you're actually buying back is room in your own context window. That's the context fidelity trade. You free up space in the orchestrator's window, and you pay for it in the sub-agent's grip on what you meant. There's an asymmetry underneath that trade, and it only cuts one direction. You can always buy more tokens, a metered bill. Buying more context window mid-conversation isn't something many solves, so a full session starts losing track of things it still needs. That's also where scale shows up. Below roughly a few hundred identical shape items, a sub-agent per item wins on the context savings alone. Past that range, a flat loop against the model's API tends to win instead, because the returning summaries become the real constraint. That's an operating heuristic from running both patterns myself without a precise cutoff. A sub-agent starts with a context window that's fresh and isolated. Anthropic says so directly in the Claude Code docs. It doesn't see your conversation history, the skills you've already invoked, or the files you've already read. Everything past that comes from what you actually type into the delegation message, so a dropped constraint has no shared memory to recover from. By default, Claude Code guards that isolation structurally. Nested delegation stops at 3 layers below the main conversation, and at 200 total spawns per session before it refuses to go further. Those are vendor defaults, confirmed directly in the docs, and yours to change if you need to. A nearby academic paper, arXiv 2607, 23809, actually studies something adjacent, a single agent managing its own accumulating context, different mechanism from agent to agent delegation. I'm reading the connection here as my own inference about what a sub-agent loses. 3 failure modes show up once you run this in production, and I have hit all 3 myself. Fixed framing fabrication is the most dangerous. Asking to fix something, an agent will sometimes report a fix it never made because the prompt framed a fix as the expected answer. Uncapped fanout depth is second. Nest more than 1 layer deep, and a sub-agent works from whatever the layer above passed down, losing the original intent along the way. Interrupted heft writes are third. A killed agent can leave a file with a new header on top and the old body underneath, so the orchestrator's last message reports what it meant to do, while only a fresh read confirms what it actually finished. One way to check this yourself: run the same task twice, once in line, once delegated to a sub-agent that returns a summary. Then ask a specific follow-up whose answer lives in the sub-agent's raw work, small file detail, or an option it discarded. If the orchestrator can't answer it, that gap is the context fidelity trade made visible. So every decision choice in a delegation pipeline, how much goes into the message, whether you nest another layer, whether a builder and reviewer share an instance, is a decision about where you spend on the context fidelity trade. Put every constraint you're holding silently into the message, because it's the only thing the sub-agent gets. We'll write up is in the comment section below, and I will catch you all for the next video.